Hello Blazers, welcome to episode 8 of UAB Green and Told. Through Green and Told, we are able to share the stories from members of the UAB family. I'm Greg Berry, Assistant Director in the UAB Office of Alumni Affairs. Today we're sitting down with Dr. Matt Might, Inaugural Director of UAB's Hugh Kaul Personalized Medicine Institute. A relatively new member to the UAB family, Matt's UAB story started before even arriving in Birmingham. In fact, it began around the time his son, Bertrand, was born.
I think by 2 months old, something didn't seem right to me. He appeared to be diverging from the American Academy of Pediatrics guidelines.
And as Matt shares, that's when he embarked on an odyssey to track down a disease virtually unknown to anyone.
It's devastating as a parent to go through this because not only are you watching your child suffer, but you don't know why. And it's just agonizing.
And indirectly, it was Bertrand who led him to UAB and into the role of the Personalized Medicine Institute's first ever director.
With UAB, it was a commitment of the Institute, of the health system, of the leadership, almost really of the state itself, to say, let's do genomic medicine here in Alabama.
As an 8-year-old, Matt Might's dad gave him his first computer, a junk computer that he started to poke around at. By the time he enrolled at Georgia Tech as an undergraduate student, he knew his career path would involve computers. Ultimately, he found himself specializing in the field called programming languages. While finishing his PhD, he and his wife found out that they were expecting the first child. Not only did it accelerate Matt's plan to complete that degree, the pregnancy would change his life and career path forever.
Yeah, when I realized she was pregnant, she said, "You're graduating this semester," and so I did.
Yeah,
I mean, it was fortunate that I could get out then. Spent a year actually doing startups, and that's when my son Bertrand was born.
Okay.
And realized that it's good to have a job with health insurance, and also I knew I wanted to go back to academia, so I was applying to academic positions and ended up taking a professorship at the University of Utah.
So in 2007, Bertrand was born, and it was just a matter of a few weeks when you realized something's not right.
Yeah, I think by 2 months old, something didn't seem right to me. He appeared to be diverging from the American Academy of Pediatrics guidelines. And I literally had the book, this 2-inch thick book that you could check to see where your child was developmentally, and I thought, that's weird. But at the time, no one really was like, okay, there's really a problem. And it was at 6 months old where we said, oh, there's definitely something wrong. At that point, his pediatrician said, yeah, there's definitely something wrong.
What kind of things was he not progressing on?
So he was having a difficult time, crawling, with standing, anything resembling speech seemed very delayed. And I noticed, there was a very unevenness to his movements. So he wasn't making clean circular motions. He was making very jerky movements. We called him, at the time, jiggling. Yeah, because for lack of a better medical term, he didn't seem stable. He wouldn't sit still. He wouldn't really, control himself. He just seemed to always be in motion.
So as a parent, that had to have been just tremendously hard for both you and your wife.
Yeah, initially it was just puzzling, like what's going on here? And I think the real shock came at about 8 months when we just moved to Utah at that point. I'm in my first faculty meeting and I get a stream of calls and text messages from my wife saying, we just had his developmental pediatrician's appointment and they think he has brain damage. So that was my first day on the job, and that was the day that we realized that something was very seriously wrong with Bertrand.
And you didn't buy into that?
I didn't know what to make of it. I thought, gosh, brain damage, that's a pretty serious diagnosis. Yeah. So he was scheduled for an MRI, and turns out he didn't have any visible brain damage, any structural abnormalities that they could see, but something was wrong. He was not hitting his milestones for sure. So there was a long sequence of potential diagnoses that followed. They said maybe he has ataxia telangiectasia, and maybe he's got Rett syndrome, and maybe just this laundry list of genetic disorders, and rare congenital conditions were thrown out as possible diagnoses, and none of them really stuck. None of them fit.
you're getting all of these diagnoses for him one by one. I mean, you're checking them off. Okay, it's not that. It's not that. That couldn't have been easy going through that process because you, as a parent, want to find out what the heck's wrong.
Yeah, no, it's devastating as a parent to go through this because not only are you watching your child suffer, but you don't know why. And it's just agonizing because I remember like holding my son at night, not being able to comfort him and not knowing why I couldn't comfort him, having no idea what he was experiencing or going through. And around that time, we started to find other communities online of undiagnosed patients, and I realized that, wow, there's a lot of parents out there going through this exact same struggle.
Concerned, the University of Utah computer science professor didn't sit back and wait for answers. Instead, he was proactive in his search to find out what was wrong with Bertrand.
At that time, all I wanted to do was find an answer for my son, and so when I'd meet other parents, we would try to figure out does my child have what your child has, and invariably the answer would be no, and it was a search, and it was during that period, which we call the Diagnostic Odyssey, that eventually we, after about a year and a half, came to the conclusion that we need to look into his DNA. And for me, at the time, as a computer scientist, I had a very simplistic view of DNA. I thought, well, DNA is just a long string of letters. I've got one, Bertrand's got one, my wife has one. Can we just compare ours to Bertrand to see where he's different? Can we look for those mutations that make Bertrand different from me and her? And so I proposed that to the genetics department at Utah, and they said, well, yeah, it's theoretically possible to do this. Okay. It's going to be really expensive to do it. I think they quoted $500,000 or something like that at the time. And as I said, okay, well, if it's theoretically possible, then we'll start raising funds or something like that to make it happen. And then overnight, a technology that accelerated the whole process, I mean, literally overnight, this new technology called exome sequencing came out as a research technique. And it dropped the cost by probably an order of magnitude or two. I mean, almost instantaneously by sort of efficiently sequencing the part of the genome that's likely to encode disease, the region that encodes proteins. So, which is only about 2% of the genome. It's very tiny. And so it was a sudden game changer emerged out of nowhere. And I think that's when I really started getting more and more interested in medicine. First in genetics, obviously, because that's what we had to engage with to get an answer for Bertrand. And so I started to learn sort of the basics of genetics and how to even propose this experiment to find out what he had.
So what did you decide to do with that experiment? What was that like?
Yeah, so the proposed experiment, which we ended up executing at Duke University with a team of researchers there, was what they call trio exome sequencing. And again, he was one of the first humans in the world to have this done, where, again, they looked at my exome, Christina, my wife's exome, and Bertrand's exome, and they compared them to see. Again, the hypothesis was there's probably some mutations that occurred in Bertrand that gave him his disease. We call these de novo mutations. And that's just because my wife and I are sort of demonstrably unrelated to each other. We have very different ancestries, and so it seemed unlikely we had a common ancestor that could create a classic autosomal recessive disorder. And it turns out he does actually have an autosomal recessive disorder. My wife and I each carry a mutation in a gene called NGLY1, different mutations that both break this gene. And so what we found was that he was, in fact, the first person ever diagnosed with this brand new genetic disease called NGLY1 deficiency.
So he's diagnosed. And then what? I mean, he's one in the world at that point,
right? At
least being diagnosed. So it's not just as easy as going down to the hospital and saying, hey, can you fix it? Can you help? So what was the process once you figured out what it was? Because it couldn't have been easy at all.
No, I mean, the team at Duke was really amazing. I mean, they were very honest in the sense they said that, well, it's a brand new disease. No one knows how common this is yet. Well, they said for sure it's extremely rare, and we could put some bounds on just how rare it was. We knew it was a one in many millions kind of disease. And they said, it could be a decade or more before you ever find a second patient. They said, obviously, there's no treatment. And there's no drug company that cares about this. There's no research being done on this. So they said, if anyone's going to do anything about this, it kind of has to be you.
Yeah. Which seems to be a common theme with everything.
It is. I mean, that's a theme within precision medicine is patients really pushing the research and pushing the science on behalf of themselves. And I guess just because I had been a practicing scientist as a professional, I thought, okay, well, if we have to do some science, let's just do some science. And to me, it didn't matter so much that it was biology instead of computer science. Well, I mean, it's just another kind of science. Let's do biology now. Unquestionably, there was relief. I mean, to not know what it was for so long, and to finally get an answer meant, well, first of all, we didn't have to search anymore.
Yeah.
We finally knew what it was. And not only did we know what it was, we knew the exact molecular defect. We knew there was a missing gene. And so we could say, well, that's what we have to fix. We have to fix this very precise molecular defect.
You go from one question mark of not knowing what's even going on to now, where do we go from here? So what laid out from the time you figured out what was wrong, going to San Diego and all of that?
Yeah, so at that point, the question was, okay, it shifted from what is it to how do we compensate for this missing gene? That became the new question. So that involved understanding the gene. And so there was probably a 2-year process where we engaged with basic science with Hudson Freeze on figuring out what this gene really did. And we had some sense of what it did. I mean, it wasn't an unstudied gene, certainly was an unstudied disease. And at the same time, we said, well, we have to find other patients. You can't have just one family take on an entire disease. That doesn't work. And I knew that there had to be other patients out there. They just didn't know what they had. I estimated there's somewhere on the order of a few hundred patients worldwide that have this. So to find them, I wrote a blog post that was very deliberately designed to go viral and rank highly in Google search results. So I wrote a blog post called Hunting Down My Son's Killer. It's got a very dramatic, catchy intro and a picture of Liam Neeson up at the top, and it really did take off. And so it was seen by millions of people very quickly. And then it started ranking highly if you typed in search terms like lack of tears, which is one of the major symptoms of the disease. And so other patients started to find us. I mean, literally within 2 weeks, there was a sibling pair in Turkey with the same disease, didn't know what they had, but realized that this is what it was from that blog post.
At the time, what was your son like? Obviously, I have him at about 6 years old at this point.
Yep. So he's about 6, and he has extreme developmental delay. So mentally, cognitively, he's around 9 months of age. He has extraordinary movement disorder in the sense that he's got issues with gross motor control, issues with fine motor control. He's got a seizure disorder, so he was having on the order of, probably 100 seizures a day. I mean, it was
Wow.
a lot of seizures. And on top of that, to make matters, difficult day to day, he could not cry tears. So he could cry, he could have the emotion of crying, but he would never make liquid tears, ever. And his eye moisture in general was just very low. And so, we were constantly trying to keep his eyes lubricated and preventing them from going dry, because at that point, he already had eye surgeries to correct the infections in his eyes. Like, they literally had to go in and drain pus out of his eyes. And they recommended actually that we sew his eyes shut with a procedure called a tarsorrhaphy, just to protect his vision.
Oh, wow.
Yeah, it was pretty extreme.
At this point, Bertrand finally has a diagnosis as the first patient in the world with NGLY1 deficiency, which provides at least a little relief for Matt and his wife.
Yeah, there's real power in community, unquestionably, to know that there are others out there, that you're not alone, and that you can work together to fight this disease. And in fact, other patients volunteered right away. And we were able to convince the NIH through amazing researchers like Bill Gaul and Lynn Wolfe to allow all of these patients into a natural history study so that they could come for 1 week every year, more or less indefinitely, to be studied so we could understand what this disease was really doing to these patients. And that combined with the basic science really gave us some insights on what to do about this disorder.
What did you do?
So the first thing, about 2 years in, by the time Bertrand's 2 years old, that was when I was able, I knew enough to make a prediction about what might help him.
Okay.
And in a nutshell, I was able to predict that as a consequence of missing NGLY1, he was going to be missing something else. That he was going to be missing a metabolite that he was going to be in short supply of. And that particular metabolite happens to be called N-acetylglucosamine, which again, to me at the time didn't mean a whole lot, but it was something I could Google. So I Googled it and realized you could buy this thing on Amazon. Like you could buy a jar of it, you could buy a bag of it, it'd be on your doorstep in 2 days. And so I'm sitting there thinking, well, my little theoretical model says Bertrand's missing this, and I can buy it. So that's where we were after about 2 years.
So Dr. Mike got resourceful and went online to purchase an acetyl glucosamine.
It's an unusual sugar. You wouldn't typically eat it unless you're eating the shells off of shellfish, which is where it's typically, if you produce it in industrial quantities, they typically extract it from the shells. So, I was reasonably confident it was safe, but just to make sure, I ate an entire bag of it myself in one sitting. And I woke up alive the next day, and I figured, well, that's FDA phase 1 safety testing complete. And then gave it to Bertrand, and didn't know what to expect, had no idea what it would do. Thought maybe it'll help with seizures, maybe it'll help with movement disorder, maybe it'll help with development. What it ended up helping with was tears.
Okay.
So he was able to lubricate his eyes sufficiently to where he hasn't had to have eye surgery. His corneal erosion stopped. His vision's quite good today. And he can, in fact, produce tears. So that's what that did.
At this part of Matt's career, he was still in Utah, about to become a tenured professor. As we'll find out after a short message from the UAB National Alumni Society, this is also when his journey, which includes leading him to UAB, changes paths.
Whether it's for an incoming undergraduate or graduate student, the UAB National Alumni Society has scholarships available for you. Students and parents are invited to visit alumni.uab.edu/scholarships to check out all of our NAS-sponsored awards, including special awards for legacy students. Applications for the 2020-2021 school year are now being accepted. To find out more, visit alumni.uab.edu/scholarships.
Welcome back. During the time of discovering Bertrand's diagnosis, Dr. Matt Might was still focusing on computer science. But now, he also started getting interested in what is now known as precision medicine.
That moment in history, the term precision medicine wasn't really out there. It was coming on. I mean, it was being defined in a National Academies report, but it wasn't in the public consciousness. No one in medicine knew what the term precision medicine actually meant outside of about 10 people who had just defined it. So, I mean, at that time, I was still very dedicated in my work in computer science, but I was obviously getting attracted to what would eventually be called precision medicine, where you work with things like the root molecular cause of the disease and you treat it there. And just in the course of trying to help Bertrand, I was encountering all the concepts and the ideas that would come to form this new field of precision medicine. Okay.
So where did you go from there? Where did that exactly lead to? Because you're still in Utah.
Yep, still in Utah. At that point, I was about to get tenure in computer science at Utah, so I got tenure, and I didn't take a sabbatical right away, but I started engaging with the NIH more, and the thing that really sort of where things took off was a professor at MIT named Seth Mnookin followed our family for the 2 years after the blog post, and he wrote an article for the New Yorker about our family and about this whole odyssey with Bertrand. And that landed on sort of all the right desks. So right as I was getting tenure, this article comes out, and it lands on President Obama's desk. It lands on the NIH director's desk. I mean, everybody starts reading this article. And this is 2014, so I'm getting tenure, and that's the summer where Obama starts to formulate this idea of precision medicine as an initiative. It's something he'd been a fan of since he was a senator, and back when it was called personalized medicine or genomic medicine. And that summer, this article lands on his desk and he says, "That's what I want." And so my life started to split at that point. I picked up the second professorship in pharmaceutical chemistry because I said, hey, I want to actually develop drugs for this disease. And just got engaged with the Undiagnosed Diseases Network, which was run out of Harvard at the time. Got pulled in by the NIH on some conversations around this sort of stealth project. And then in early 2015, about 6 months later, I was invited to the White House. I ended up meeting with President Obama, where he revealed that I had been working on the Precision Medicine Initiative and asked me if I wanted to continue working on the Precision Medicine Initiative. And of course, I said yes. And so that began what became a 3-year engagement with the White House. 6 months later, I joined the faculty at the Harvard Medical School. And that began a parallel odyssey where I started going back and forth between the White House and Harvard for about, again, 2.5 years at that point. And so at Harvard, I was working on applying precision medicine. At the White House, I was working on setting up this initiative that would lay the scientific foundation to do precision medicine at scale.
And somehow, right around that time, you also wind up here in Birmingham.
So about 2 years into all of that, there was an election, and I had to start thinking about what do I want to do for the future, and right around that time, got contacted by UAB saying, would you be interested in setting up this Precision Medicine Institute? And I said, and this is around 2017. I said, yeah, actually, that sounds very interesting. Tell me more. And so ended up coming and interviewing at UAB. I think it was clearly a good fit for both sides, and so shifted gears. Instead of heading up to Harvard, I came down to Birmingham and set up this institute.
That decision was made despite not knowing much about Birmingham. Even with that in mind, it wasn't as difficult of a decision as you might think.
It was a much easier decision to make than I anticipated. Harvard had made a very compelling offer at that point, but the offer from UAB was overwhelming. There was no contest as to where it would be easier to realize this vision for precision medicine. And with UAB, it was a commitment of the institute, of the health system, of the leadership, almost really of the state itself, to say, let's do genomic medicine here in Alabama, and let's make UAB be the driver and the leader in this new field. It was just an extraordinary offer. And so it was very easy to accept at that point.
How has everything changed within that department since you've got here and to where we are now, 2.5 years later?
So 2.5 years later, we have started to demonstrate that precision medicine is very real. We are impacting patient lives regularly, all the time now. We are in the midst of moving the initial prototype programs that have been created at the Precision Medicine Institute into the health system. So for example, Bruce Corf, by the time I got here, was leading this undiagnosed diseases program, which uses cutting-edge genomics to diagnose patients, and that's transitioning into the health system. When I got here, I started, from my own research, creating a personalized therapeutics program, so that patients could reach out and we can engage in this consultation process with them and their physicians to push them through their own therapeutic odyssey, if you will, so that we could try to find solutions for them that were truly tailored to their individual characteristics.
What was the initial goal when you did get that position?
For me, the goal was really to demonstrate that Obama's vision of precision medicine was real. So Obama, whenever he would talk about precision medicine, would use examples like Bertrand's story and other stories where we've been able to precisely diagnose and tailor treatment to a disease. And I wanted to show that Bertrand was not a one-off, that we really could do this again and again and again. And so I'd done some of that before coming to UAB, but I wanted to show that we could create a process for doing this over and over and over again, and knowing that in some cases it would take years to go from a diagnosis to a treatment. In some cases it would take years to get to a diagnosis, but that there was going to be a distribution, that there were going to be some patients that we could help relatively quickly, where we would have enough data just from knowing the genetics that we could predict potential treatment for them, and then work with their physicians to see if that was something that was clinically reasonable. So we set out to do that and got overwhelmed with the response in a great way. So we've had hundreds of patients reach out in the last 1.5 years saying, please help. And we're now moving all of them through their own individual therapeutic odysseys, and some have actually landed in that time period on treatment recommendations. We've had dozens of patients get reports sent to their physicians saying, this is what the research indicates could be a plausible route for that particular patient.
What's your department like now? How many people are working there?
So within the Institute, I think we have somewhere in the order of 9 faculty at this point.
Okay.
We had an amazing year in terms of recruiting some really superstar faculty to come to UAB. And we're finally assembling the team that can really deliver end-to-end on precision medicine. I think that's been the key thing that's happened in the last year and a half, really. So 9 faculty in the Institute, probably hire some more this year, rounding out the talents we need to really deliver. And I would say it's an active, it's an energetic place. So we do case reviews every Monday.
Okay.
And we invite outsiders to come to that because any identifying information on patients is stripped away. We just focus on the science, and you'll get anywhere from 50 to 100 little miniature episodes of House over the course of a day, where we dissect each case and try to figure out, based on any new information we have, what else we might do for that case on the journey for a therapy.
Is UAB helping kind of pioneer the industry of precision medicine?
Absolutely. I don't think there's anywhere else in the country that's doing this right now. This is I think a truly unique to UAB program. And to have all the research really driven by patient needs, that's a bit unusual. But it's also very deliberate.
Mm-hmm.
And we are very focused on doing the research that will ultimately benefit patients.
Where do you see the Institute in 5-10 years?
So I see the Institute as an accelerator. And so I hope by then we have acquired all the faculty that we need to really execute at scale on this vision for precision medicine, that we are also sort of an engine that regularly prototypes ideas for precision medicine and then transplants them into the health system. That's the goal, is to be an engine for research into proof of concept or prototypes for precision medicine that the health system can then adopt.
And it all started because of Bertrand.
And it all started because of Bertrand. I mean, I would be doing cybersecurity these days if not for Bertrand. That's the arc from computer science with a full pivot all the way into medicine. Now what will be a lifelong focus on precision medicine thanks to Bertrand.
I think it was about 6-7 years ago, you had mentioned there were probably only 10 people that knew really what precision medicine was.
Mm-hmm.
What's that world like today?
Well, now precision medicine it's the hot term. There's a lot of hype and a lot of hope, but honestly, a lot of promise to it too. I mean, I think it's very real. And so there's all these conferences around precision medicine. There's all these precision medicine programs that are starting up around the country. And I think I think I've been able to distill the essence of precision medicine. And the way I say it, precision medicine is really ultimately about optimizing health with data. And genomic data is one powerful source of data for that optimization process, but ultimately everything counts. That can be social media data, Apple Watch data, your electronic health record data, all of that can feed into this constrained optimization process. So it's really about harnessing the power of data to find the best possible treatment for every patient. And a lot of time that we do use genomic data, but sometimes we don't. Sometimes it's old-fashioned detective work combined with cutting-edge AI that actually makes the difference for a patient.
What's Bertrand like now?
These days, Bertrand's benefited from I think it's a total of 3 therapies that have been discovered since the diagnosis of his disease, with a 4th clinical trial coming online in February. And we finally have, over time, been able to move the needle on the developmental aspects of his disease. And so he started to get pretty good at using an eye-gaze computer.
Okay.
And if, for example, I came home about a week and a half ago, and when I walked in the door, he was able to use his little computer to say, hello, Matt is my dad.
That's awesome.
And this past Monday, when he was eating yogurt, he was able to say, like yogurt, more yogurt. And when he was going to bed, he was able to say, like reading, more books. It's amazing to me that a child who'd been, in some sense, trapped and held back for so long is able to now be so expressive in his communication.
That's got to be a tremendous feeling.
It is. I think what every parent wants in life is for their child to be happy. And I've reached a point now where Bertrand's seizures are under control. His vision is protected. He's able to communicate his desires and intents, and he's able to experience happiness and tell us what will allow him to experience happiness. So, most days he's happy all day, every day, and that's really all any parent could ask for. I tell people that as scientists we love our metrics, but I think the most important metric at the end of the day is the one that we measure in smiles per hour.
I asked you a few moments ago where you saw the Institute in 5-10 years. Where do you see Matt Might in 5-10 years, 15-20 years?
Yeah, well, I feel very committed to precision medicine. For me, the personal has become the professional, so it is hard to imagine doing anything other than what I'm doing right now. What I really hope is that in 5-10 years that what we've done is scale this up at UAB, that everything we're doing for the hundreds of patients we see right now has been scaled up to so that every patient that comes to UAB gets this kind of treatment regardless of their condition, and it's just integrated into the fabric of the health system. That's what I'd like to see in 5 to 10 years. And honestly, I hope that long term that we're so successful that precision medicine becomes so ubiquitous that people just expect it by default, and that we don't even call it precision medicine anymore, that we just call it medicine. So if we succeed in this mission, if we succeed as an institute, we will succeed ourselves out of existence and just disappear into the fabric of medicine itself.
Dr. Matt Might has served as the director of the Hugh Kaul Precision Medicine Institute at UAB since 2017. He also serves as the Hugh Kaul Endowed Chair of Precision Medicine, a professor of internal medicine, and a professor of computer science. While he may be new to UAB, he still has an answer for what does it mean to be a Blazer.
I think to be a Blazer, I think first and foremost it means you're a team player. When I came to UAB, one of the things I knew I needed was an environment where everybody worked together. You can't do precision medicine alone. You have to have everybody on campus on board, because you never know who you're going to talk to for the next patient. And it could be a basic scientist that you need to talk to. It could be a clinician that you need to talk to. But it's always going to be driven by the scientific needs of the patient. And so that you have to have a collaborative faculty. You have to have that collaborative spirit. This isn't just a school, it's a team. Everybody here is on Team UAB, and we are all working together. And so that to me is the essence of being a Blazer, is being that team player.
If you would like to learn more about Dr. Might, Bertrand, and NGLY1, check out our podcast page at alumni.uab.edu/Green and Told. Wherever you listen to our podcast, be sure to leave a review. Have a question or a future topic? Email me at greenandtold@uab.edu. You can also find us on Facebook and Twitter at UAB Alumni and Instagram at UAB_Alumni. Thanks for listening, and until next time, go Blazers.